So I'm hoping to be a little bit of an ambassador of things, okay, between security and applications, actually security and development or code. So hopefully that'll become a little apparent as we go through this, but it's actually quite nerve-wracking for me. Has anybody ever seen a talk that I've given before in here? Probably no hands, I would not expect, okay? Normally when I go speak at a conference, I'm at a security conference, and 90% of the people in there have heard me speak, at least whether it's on YouTube or whether it's in person. So this is like way out of my comfort zone here, but I believe that growth comes from pushing myself out of my comfort zone, and so this is nerve-wracking for me, okay? So who here is not a developer? Cool, so I got 4 other people in here that are not a developer. Well, guess what? And I just really had to find a way to use these boards. I showed up yesterday, I'm like, these things are cool. I gotta figure out a way to use these. So, here we go. I am not a developer, okay? I've never held a job where the title had the word develop in the title, okay? So that's a pretty big deal because Barry made a huge mistake. Like, why would I be keynoting a conference, a developer conference, as somebody that's never actually been a developer, okay? So if you guys have a problem with that, you guys know who to address that with. Okay, but so it's a good thing that this is called a code conference and not a developer conference, because while I've never been in a job where I've been called a developer, I've written a ton of code in my life, okay? So I'm gonna age myself a bit here, and I don't mind, I'm 45 years old. I started writing code in the 1980s on an IBM XT80. Does anybody even remember what one of those is? Like, it didn't even have a hard drive. It's like 128K memory, that was it, right? DOS 6.22, wrote my first line of code on that, just trying to make video games easier to play because I was tired of configuring drivers and having to remember what commands to type. So I just like made a little menu system where I could hit a button, it'd tell me what disk to put in, and it'd launch my games. It drove my dad absolutely nuts because he was trying to use it for word processing. So I wrote my first code back in the 80s. I wrote my first production application for a company called Progress Lighting. I don't know if anybody's heard of Progress Lighting. It was a company in Greenville, it became Hubble, and then I think it's maybe something else now or whatever. I didn't even know I was doing it. My dad was like, hey, I got a problem at work. I need somebody to solve this. Do you know how to do this? And I figured it out how to do it. 12 years old, wrote some code that he ran in production there. So I did a little bit of that. And even though I've never been a developer, through my military career, through my business career, and through my security career, everywhere I have gone, code has been a major part of my job. I've never been the smartest person in the room, but quite often I was the most efficient person in the room because I knew how to code. Whether I was doing spreadsheet work and managing stuff with, whether it's Google Sheets. I've actually written an application that ran on Google Sheets, by the way. Maybe we can talk about that later. But whether it's using like Google Sheets or Excel or something like that, the ability to code has made me more effective and more efficient in that. For those of you that raised your hand and said you were not a developer, you're in a very good place because learning how to write code, learning about code is going to make you better at pretty much every single job you do this day and age. Okay, so keep that in mind. All right, so what are some of the technologies I've dealt with? You gleaned a little bit of that based on what I just said, but I've dealt with QBasic, I've dealt with VB6, VB.NET, PHP, Python I've written apps in, C# I've written apps in, front ends, Vue, React, HTMX is something I'm dealing with a lot now. I don't know if any of you are even familiar with that. I talked to a lot of people that have never heard of it before, but HTMX has been kind of a fun experiment that I've been playing with lately. So I've been writing a little bit of code in that. So I have some code experience even though I've never been a developer. So what am I then? Well, if it's not clear already, I'm a security guy, okay? Security is what I do. And I've been doing it for a long time. Since, not nearly as long as I've been coding, but I've been doing security since probably 2008-ish. Okay, 2008-ish, I went into the Army, did this thing called Red Team. So I've actually had a lot of job titles with security in the title, or security-ish terms. I've been a leader of a Red Team there. I've been a junior consultant, I've been a senior consultant, principal consultant, a VP of professional security services, those types of things. So I've done a lot of things in the security industry. So I'm not a dev, I do security. I'm not gonna sit up here and try to pose as a developer because that's not what I do. But what I'm gonna do is be technical and present to you something that I think will help you as developers as you seek to write code around these things called JSON Web Tokens. And so that's the gist of what we're gonna get into today. I'm also not a thought leader. Okay, So I don't like have this whole forward thinking mentality. I live very much on the tactical level down here working on the front lines of things. That's where I like to be. So that's what I'm going to talk about today. And I think most of you will appreciate that as well. Okay, so let's go ahead and get started here on JWT misuse and abuse. So I've already talked a little bit about who I am, but I think the thing that defines us more than anything is why we do stuff, right? Some people chase success and celebrity and popularity. Other people chase money or whatever it is. I'm not really chasing anything other than favor, okay? So for me, the reason why I do everything for the better part of the last 15 years has been my faith. That's just who I am. That's where I come from. I'm not good at a whole lot of things, right? I like to call myself like a one-trick pony. I've got one trick, but I do that trick pretty good, okay? And so I believe in using that one trick to just try to make the world a better place. And I do it all because of my belief. I do it all because it honors the creator that gave me that particular gift. And so if you ever have any wonders about why I do what I do, that's what it is. And so because of that mindset also, the time that I spend with you over the next 45, 50, 60 minutes, I'm going to give you everything I got. I'm going to give you the best that I have because that is how I honor my creator there, okay? So here's just some general things about me. Husband, father, veteran. I do a lot of security testing, of course. That's part of what this thing over here means. Solopreneur. I'm a one-man company, okay? So it's just me doing my thing. But I do a lot of training, okay? I do a lot of actual work in code, okay, helping remediate and fix problems and solve solutions. Do a lot of testing code, which typically leads to the other one. So anything that has to do with the combination of security and web applications, that's where I live. And so I would deal with developers every day, working in DevOps processes and DevSecOps processes, the whole 9 yards. Anywhere those two things overlap, that's where I work. There's a company called Portswigger. I don't know if you've heard of that. We're going to be using some of their software today to do some of the demos. It is kind of the main piece of software that we use in web application security. I'm one of their preferred training partners. Just kind of throw that out there. But I just deal with everything within the realm of HTTP, basically. So outline today of what we're going to talk about from a technical perspective here. First, what are JWTs and what are claims? If you've dealt with them before, this is probably pretty basic stuff you already know of. We'll rehash it quickly so that anybody that's not familiar with it will get caught up with us. We'll talk about why they matter, talk about some use cases for some JWTs, and then we'll jump into some misuses and abuses that I've actually done myself, okay, or have witnessed or found that other developers have done as well. So we'll talk about some use cases there within various categories of their uses. Then we'll conclude with some stuff and throw out some slides about some general resources and credits attribution for some things that we use within the talk itself. Okay, so what are JWTs and what are claims? Who here's ever read an RFC before? Oh, wow, good. Okay, so I'm not the only nerd in the room, okay? Or the only person that didn't need to fall asleep. Because I'm telling you what right now, if you want to learn something well or get rest, reading an RFC is a great way to do that because it's going to put you to sleep or it's going to teach you something. One of the two, depends on how interested you are, right? So RFC 7519 defines what a JSON web token is, or it's kind of the beginning of it. There's some other RFCs that support it, but that's the main and it defines a JWT as a compact URL safe means for representing claims to be transferred between two parties. And the part that I want to focus on here is just the URL safe piece, right? HTTP, that's the protocol that web applications live on. I know this is a code conference, so we're talking about a lot of different types of code, but I mainly live in any type of code that operates across HTTP, so that's what I'm going to focus on here. But when we're talking about web applications, they communicate through URLs, right? And so this is a really good solution to be used with the HTTP protocol, and they're just transferring these things called claims. Okay, so the next natural flow of this is, okay, if this is a URL safe means for representing something or transferring something, what are these things that we're transferring? They're claims. And so a claim is defined as a piece of information that's asserted about a subject, and a subject would be whatever that token is about, okay, the subject of the token. But it asserts something about the subject, and it represents it as a name-value pair. So you can see these things down here, name-value pairs. I am certain any of you have seen something that says something equals something. That's a name-value pair. That's all it is. And we put more one of those together, it forms a JSON, a JavaScript object. So this is JavaScript object right here. It's where we get JavaScript object notation, the part of JSON web token, right? It's a JSON or JavaScript object, okay? So this is when you bring multiple properties together, JavaScript properties together, you get a JavaScript object, and then when you put a JavaScript object together inside of a JWT, it's referred to as a claims set. So these are multiple claims and they form a claim set. And the name part of a claim set can fall into a couple different categories or types. Registered, public, private. Don't want to get in any detail about what those mean. They're defined in RFC 7519. Just know that none of them are restricted. Okay, it's pretty open, pretty flexible. You can use them however you want, whenever you want. There's nothing in the spec that requires you to use certain claims in certain ways. They just specify ways that you should use those for interoperability, just like any other standard. But so the importance of that isn't so much. Just know that they're name value pairs, and you put them together, and you have what's called a claim set. But that still doesn't really make us understand of why they're called claims and not just properties, right? Because if they are just JavaScript object properties, why are they called a claim? Well, it's because of this. There's an untrusted element here. Okay, so when you're dealing with a JWT, you're often dealing with three different parties. You're dealing with an issuer, you're dealing with a subject, and you're dealing with an audience. And an issuer is this thing that provides the token. It's the thing that creates it and sends it out. And then you have the audience, which is the thing that receives it and processes it. But quite often there's this intermediary, okay? Quite often there's an intermediary that is untrusted, that actually handles that particular token. And so the information that's in it is not truth yet, okay? It could be truth, it's potentially truth, but right now it's just a claim until the resource server takes those claims and validates them and verifies them as truth. So when we're talking like in the English language, when we talk about the word claim versus a fact, right, those are two different things. A claim is not a fact. It's the same thing when we're talking about JSON Web Tokens. It's a claim until it's proven to be factual about that particular subject. And you see that relationship right here. You got the authentication server, which provides a JWT. You have the resource server, which wants to do something with it, but it can't trust it because it's actually being communicated through this client. Now, it doesn't always happen this way. This is just a form of this here. Okay, but that just kind of demonstrates the idea of why it's called a claim, because it's coming from an untrusted source and it has to be verified. All right, so integrity is really, really important when we talk about JSON Web Tokens. A claim should never be trusted until two things are verified. One, the origin, and two, the integrity. Did this thing actually come from a trustworthy resource, number one, and then has it been changed at any point in time between the initial issuer and me as the audience? Those two things have to happen. So anytime we're talking about integrity, who here is familiar with the CIA triad, the security triad? Just a couple of hands. Okay, so security is based around, there's three different things: confidentiality, integrity, and availability. Okay, integrity is a big part, one of the three major pieces of security. And so for those of you that are security minded here, or maybe you're not, what's the main thing we use to ensure integrity? Some sort of signature, okay? We sign things, that's what signatures are for. They ensure integrity. So within JWT, there's actually different structures that you'll come across when you're dealing with JWTs. And the primary one, the default one, probably the most common one that you're gonna come across is what's called a JSON web signature or a JWS structure. Okay, and this is where the signing process has been incorporated into the JWT so that these claims can be verified as trustworthy. So if we look at this down here, this is kind of a breakdown of a JWS. Okay, and this is what you would see. Of course, it would all be joined together without line breaks, but that's what you would see actually communicated via the URL or a header or the body or something like that. But it's broken into three different pieces. And basically, you have the payload, which is the claim set. Okay, you have the claim set. This is the piece of information that we're trying to validate or validate as fact. And then we have a header that tells the resource server how to check the signature. And then of course we have a signature that's attached to the end of it. You see those three pieces broken down here. So we want to try signing these right here. It's going to give the resource server, the receiver, the ability to turn these claims into facts and trust them. Okay. So sometimes integrity is everything, is all you need, okay? But other times integrity isn't enough, okay? So JWS tokens, JWS structured JWTs are actually transparent. What we mean by transparent is they can be decoded in some way, shape, or form to see the internal contents of it. When we talk about data being opaque versus transparent we can decode, see the contents, opaque we cannot. So JWS structures, JWS tokens are actually transparent, which means we can see their context. And that's not the context. That's not always a problem, but sometimes it is. And so there's another type of structure that's available to us within the JWT spec, and that is JWE, JSON Web Encryption. And so this adds what we would say, this adds the other part of the security triad, which is confidentiality. This will now make not only this the trustworthy, but also the intermediary will no longer be able to actually see the contents of it. Confidentiality of our claim set is now ensured as well. And so the way that you would see that is, you see it broken down, there's a couple more pieces here, but this yellow piece is actually the information coming from the JWS itself. So you have the JWS that then gets base64 encoded, it gets encrypted, and then base64 encoded, and it's kind of packaged in here, and then you add these other layers on top of it that all tell the resource server how to decrypt this particular piece of information. Okay, so JWSs for signing and ensuring integrity, JWEs for encrypting and ensuring confidentiality. So why does all this matter? Like, why does this matter to you? Right? As developers, potential developers of web applications, why does this matter to you? Well, they're a core component of modern application design. Who here has heard of JWTs before? Like every hand probably going up, right? Maybe those that are not developers have never heard of them, but everybody else has heard of these before. They're ubiquitous throughout web application design. Now, not every app uses them, but a lot of them do, okay? And the other reason why it matters is because they're so commonly used, yet the spec is poorly designed from a security perspective, very poorly designed. If you've ever, maybe even if you've used JWTs, maybe you've not really looked into the history of the security behind those things, but is a really poorly designed specification from a security perspective. In 2015, when the spec was released, immediately this none vulnerability or none algorithm attack came out. The specification literally says that in the header that describes the type of signature or the algorithm that's going to be used to calculate the signature, if you set it to none, the resource server will not calculate a signature and won't verify it. So immediately, right off the bat, according to the spec, you could just set the algorithm to none, change the JWT, send it to the resource server, and it will receive it and process it. It'll trust all your claims as fact. That's really bad, right? Okay, so that was like immediately right off the bat, 2015. 8 years later, so not this past Black Hat last month, but last year in 2023, 3 more algorithm or encryption level vulnerabilities were discovered in the JWT spec. So it's just been a constant over 9-year process of continuing to find crypto vulnerabilities within the specification. It's not aged well. Okay, the crypto aspects of it have not aged well. Okay. So why not an alternative? If it's so broken, then why are we still using these things called JWTs? Are there not alternatives? Well, there actually are. There's alternatives. There's macaroons, which I think was developed by Google. There's Pacetos, and I believe I'm saying that correctly, right? There's Pacetos. There's other forms of alternatives. But the main issue is JWT has a specification. It's got an RFC. These others don't. They're great ideas, and they're probably better solutions, but they do not have an RFC tied to them. And from a political perspective, when there is an RFC tied to something, that becomes the standard. The other thing that doesn't help is you have other standards that adopt the standard. And so we have OAuth and we have OpenID Connect, and OpenID Connect specifically, which is an authentication protocol built on top of OAuth, okay, JWT is built into the specification. If you're going to provide an ID token, which we'll talk about here in just a little bit, that ID token has to be a JWT. That's specification if you want to be OpenIDC compliant. Okay, so we're basically forced into adoption here. We're forced into adoption. Okay, well, why don't we just use JWTs for the one thing and then lean on this for the rest of it? Well, because that's just a pain in the butt, right? Like, why, if I'm already using JWTs in one space, why wouldn't I just use it throughout the rest of the application in other places I need the same feature? And that's what you're going to do. So we're basically like in this place where we're kind of forced to adopt it, even though we already know it's horribly broken. So it becomes really, really important that we do it properly. Because it's not going anywhere, at least not anytime soon, right? So they're here to stay. as developers, I want you to learn a little bit more about from the attacker mindset, the way that I look at JWTs and applications. I want you to be able to look at it from my perspective, or at least see it from my perspective, so that when you implement these things, you'll think about the safe ways to do it. And then, of course, a lot of times I'm speaking to testers themselves, and if there's any of those in the room, well, you need to know how to test them so that you can help the developers that are writing the code that you're testing to do it properly and to do it safely, and so that we all live in a safer world wide web. Okay. So use cases for JWTs. A couple different categories here, and these aren't it's not like official categories for JWTs. I just kind of categorize them this way: authentication, authorization, and information exchange. Information exchange is basically like a catch-all for any type of time you see JWT that doesn't fall in these other categories. But those are the three main ways, and then the different techniques, or I guess the different implementations within the categories, there's various ones: ID tokens, refresh tokens, access tokens, client-side sessions, all of the above, plus all of this other stuff. We're going to dive into these and do some actual hands-on demonstrations of where these things how these things are implemented and how they can be broken. But this is basically how I categorize it. So my approach here is we're going to look at one example, at least one, I think one or two examples from each category, but we're not going to jump into every single one of these use cases. We just don't have the time, just a few of my favorites. We're not going to spend a bunch of time on the crypto stuff. The crypto stuff is well understood and well documented in the public domain. Now, I'm not dropping any zero-day vulnerabilities. The stuff that I talk about here does have resources in the open domain that you can go and you can find and you can learn about these things. So I'm not dropping zero-day vulnerabilities. However, I just don't see them talked about much at all. So I'm going to focus on more implementation issues, less the crypto stuff. And if you want the crypto stuff, there's a great resource, Portswigger, which I've already mentioned their website. They have a web security academy. Has anybody here ever heard of the book, Web Application Hacker's Handbook? Been around for like 20 years, there's been multiple versions about this thick. It's like the Web Application Security Bible. Well, this is the guy that Portswigger is the hacker handle, and he became a global company, that wrote that book. Okay, and basically he got tired of releasing new versions and said, I'm just going to create online material and give it all away for free rather than continue to revise this book. That's what this is. They've got a section on JWTs in there, deep dives into the crypto stuff in a way that I couldn't even do justice in here. So definitely take that resource and leverage that if you want to dive into the crypto stuff. I don't want to focus on that. I want to focus on implementation, and the examples that I'm going to show are going to be those that either I've actually done as a developer and made the mistake of incorporating that way and then finding that vulnerability later, or things I've actually found in the wild during my testing as a security engineer. Okay. All right, so another thing I want you to keep in mind is as we go through and we talk about and we show these examples, I want you to understand that the type of token, like if we're working with access tokens and we talk about one of these particular vulnerability in one of these categories where it's related to an access token, that particular technique that I go through and I introduce about how I'm going to attack that thing applies to all the others as well. So we're going to use specific attacks against certain tokens, but just know that they're not unique to any one area where you may be using a token. These types of vulnerabilities can exist in any type of JWT used for any one of these categories or purposes. All right, so first category here is JWTs and authentication. Now, most of the time when you're seeing JWTs and authentication, you're seeing them in the form of an ID token. And the reason being is because that is the output of an OpenID Connect flow. I just talked to a gentleman right here who is implementing some sort of, actually you said OAuth, not OpenID Connect. So I'll come back to you in just a minute. Okay, but if you've ever implemented an OpenID Connect client where you're like logging in your application using Google or Facebook or something like that, the end result of that Google gives back to your application is what's called an ID token. And that is in the JWS, JSON Web Signature Structure, JWT. Okay, that's what it is, and it's in the spec that it's supposed to be that way. So when we see an ID token as a JWT, it's typically coming from an OpenID Connect flow, and this is just an artifact that proves that a user has been authenticated by the issuer. Okay, in this particular case, Google or whatever. And so you see here, those are the different, that's the claim set. It's just a snippet of the claim set that would come back from that provider, and then the resource server can now take that information, verify it, and then use it, right, to create a user, to log a user in, whatever it is. Okay? Now, if you're dealing with OpenID Connect, there's actually two different flows, and they're very, very different. And this is really important for anybody doing this. There's a server flow, and then there is what's called an implicit flow. The server flow doesn't require signature verification because the token never travels through an untrusted intermediary. Whereas when you do implicit flow, it absolutely does need to be verified because it's actually going through an untrusted intermediary. But when you go and you look at the documentation for implementing an OpenID Connect client, especially when you're dealing with something like Google, it's absolute nightmarish, okay? You can start going through, because I don't know, does anybody here ever integrate with Google APIs? They've been around for a while. They've had a lot of versions. When you start looking through the documentation, you can't tell whether you're looking through the current API or the API from 5 years ago. And then you start looking through it, it's deep and it's just everywhere. It's like Wikipedia. You're just clicking on stuff and it's taking you all over the place, right? So I was actually implementing a implicit flow, but was accidentally reading documentation for the server flow, where it told me I did not need to implement signature verification. I'm like, okay, great, that saves me a whole hassle on the server side. So I just implemented it, and little did I know, ID token could be forged by anybody, okay? So yes, you need, this is a common thing that can happen. It's not just happened to me, I've also talked to other developers that fell into that same trap where I'm not really familiar with what this protocol is or how it works. I go to the documentation, I think I'm doing the right thing, but I might be looking in the wrong place, and then bad things happen. So as a tester, anytime I'm looking at an application that uses OpenID Connect, the question I ask myself is, what if the developer mistakenly trusted implicit flow like server flow? The same mistake I made, I now check up on developers. So let's go ahead and dive into a demo of this exact thing. Okay. All right, so I got a couple of my tools set up here. This is a tool called Burp Suite Pro. Okay, this is the tool that's developed by Portswigger. It's basically what we call an interception proxy. It gives me the ability to interact with and modify and do all kinds of cool stuff with the actual HTTP level of the protocol, the actual raw protocol information within an interception proxy. So I can modify things and change things on the fly. You're going to see some of the stuff that I do as a hacker right here with this stuff here in a moment. Tons of tools in here. I teach a whole class on this. So yeah, if you don't get it, that's fine. Just try to keep an eye on what I'm doing with the protocol itself, because that's what it really matters. And of course, I've got a browser here as well. I'm also going to be using an extension here called JWT Editor, which just decodes JSON Web Tokens right there inside the interface for us, so we can very easily interact with those things. So that's the tool set that we're going to be using here. Okay, there's also going to be an application. And of course, it tries to go to HTTPS. No HTTPS. Okay, vulnerability number one. There's no TLS encryption on this website, okay? But no, it's intended to be that way on purpose. But anyway, this is the web application that we're going to target. This is full of a whole suite of applications that I wrote for training. I do a lot of teaching, and every time I give a talk, these are the apps that I use. It is all available on the internet. I'll give you a link to it later. You can set it up in one simple Docker command, Docker compose up, boom, you have all these target applications with vulnerabilities available to you. So this is the one that we're going to be attacking here, and it's called Owned Hub or Pwned Hub or whatever, however you want to call that. Okay. So what I'm going to do now is I'm actually going to log in through OpenID Connect into this website. It's going to ask me for a password. So I'm going to need my password. Actually, I've got it right here. I'll just type it in. How about that? I would normally use my password manager, but I realize I may not be connected to the internet. Okay, now it wants to text me a thing. Let me do that. Anybody else get really nervous when they're doing live demos? I never do it. I never do it recorded. I am like living on the edge when I give a talk. I love to do things live like this. Oh, it worked. Thank goodness. That was the only thing we needed the internet for, so we're good moving forward from here. Okay, so I've just authenticated using the OpenID Connect process, and let's look at this absolute madness because it's crazy, okay? So when we go to our website here, I'm pulling down this, if you can see, it's a Vue front end. So I got all these Vue.js dependencies that come down, and by the way, I don't believe in a build process. I do everything without a build process. Right, I know how to use a build process. I just think it's way harder to do it without a build process, and so I kind of shoehorn everything into that, and I absolutely love it. It really teaches me about kind of the internals there. So this is the first request that goes out from my browser when I clicked on that login with Google thing. It makes this request out to accounts, and then all of this happens until that point right there. Let me close that. So all these requests, that's like the handshake. That's all the stuff that goes on between my browser and Google just to go through this process. It's pretty complex, right? Yeah, have fun in implementing that, okay? Like that's not you, right? If you're doing the server side, that's you. If you're doing the client side, like most of us are just integrating with another person's OpenID Connect provider, it's much simpler. But implementing it from the server side is difficult. But we're not worried about any of that. What we really want to look at is this right here. This is that post request, that final request from the exchange with Google back to the server that has our ID token in it. Bam, there's our ID token, okay? So we have this ID token, and once we have the ID token, we pass it in. The server side should verify the authenticity of that. Those claims now become facts, and then it logs me in and gives me an access token, and then I see users me, and then you can see the information coming back is Tim Tomes, the email address I typed in, all that good stuff, okay? So that's how it's supposed to work normally. Now, if I'm trying to make that assumption that maybe the developer didn't do things right, then what I'm going to try to do is check to see if this signature is actually being verified. And I can do that by going back to the application, and here I'm going to log out. Actually, no, I'm not going to do that. Yeah, so I'm going to take this actual ID token right here, and I'm going to right-click this request and send it to repeater. And basically what repeater is, of course I clicked on the settings. It's a replay tool. It just allows me to replay a particular request against the server. So this is that one that's got the ID token in it. I'm going to go over into the JSON Web Token area, and it gives me access, it decodes it, and gives me access to the claim set. Now if I come in here, and let's say I change owntub.gmail.com to admin at owntub.com. Now, there's a lot of ways that we could find a valid username. Email address is pretty easy to come across. We could use a username enumeration vulnerability somewhere to find out what a valid user for this is. User enumeration, not the point here. The point is, I don't own that email address, okay? That's not mine. I don't own that email address, but I come in here and I change this. Now, this is a JWS. It's signed for a reason, so that I can't do this thing, okay? If this is verified, this is not going to work. It's going to be rejected because it'll fail the signature check. But that's exactly what I'm looking for. So I change this to admin.owntub.com, and I hit send. And now I receive an access token back. Now I don't know at this point in time whether or not that access token actually works. Okay, it may be some sort of just failed access token that got created for something that I don't know. There's the whole. I got to verify what this access token actually means. Now I should probably get back like a 401 or something like that, or some sort of other error condition from the server if it fails signature validation. But I don't want to just trust that that's the case. I want to make sure. I want to validate whether or not this thing actually worked. And so I'll take this access token, and I'm going to replay it against that users me endpoint. So I send that one over to repeater as well. Let me grab the access token here. Take it over to this one and replace the access token. Send it. And if we look at this, I'm logged in as the administrator, okay? All because they failed to do the signature check there. That's all that is. It's just failed signature verification. Now, the good news is this isn't the default state of things. I'll come back and talk about remediation towards the end or responsible ways to handle this. Normally, this is, like I had to explicitly turn signature verification off in the JWT library so that this would happen. So this isn't something that's going to happen easily. You have to make a conscious decision to break your stuff in order to introduce this, okay? But I see that happen, the whole conscious decision to break your own stuff, I actually see that happen quite a bit, not so much within the form of JWTs. But this is what can happen if you forget to check for signatures, okay? All right, so that's missing signature verification. That's just to getting us started. Now let's talk about JWTs and authorization. So when we're dealing with JWTs and authorization, quite often we're dealing with access tokens. Now access tokens can be a couple of different things, okay? They can be the result of an OAuth flow. They don't have to be. Okay, they don't have to be. That's the cool thing about it. That's one of the things about OAuth is it doesn't enforce you. The JWT specification is not built into their standard. So you don't have to use JWTs, but quite often when we're dealing with OAuth, we end up handling JWTs. Okay, so that's a common place that you'll see them. Another place that you'll see them is as a temporary credential. And when I refer to temporary credentials, I imagine most people here are familiar with this idea of session. right? Where you get like a session ID, it gets sent to your browser, and as a cookie, it always sends it back, and the server says, yeah, I recognize that ID, you're good to go. Well, that's a stateful application. Usually when we're dealing with access tokens, we're dealing with a stateless application, where that access token, that JWT, is given to the client, not typically as a cookie, mostly just given to the client, and then the client has to send that back to re-authenticate with every single request so that the server knows who's authenticating, who's making this particular request, and so they can operate on their behalf. That person is actually called the bearer, and that's why often we call them bearer tokens. You've probably heard that terminology before, because someone is bearing that JWT. So we see them quite often. They're in the authorization header using the bearer keyword to be a JWT, and they can be an artifact or a temporary credential that proves that someone has authorization to a particular resource. So a couple different places that you'll see these things. And here's an example of what one might look like, okay? Very, very simple claim set here. You have an expiration timestamp, an issued at timestamp, and then you have the subject of it. Now here's the interesting thing. Anytime you're dealing with a temporary credential, and it doesn't matter if you're talking about a session or if you're talking about a token or whatever you're using as your temporary credential, something in that temporary credential has to identify the user, right? Or else it's not a temporary credential, it's just a piece of information. So something inside of it has to identify the user. It's typically the subject claim, and we see subject 6. So user ID is probably 6, okay? And that's the subject of this access token. So when the server or when the service receives that, it can say, okay, where's the row number 6 in the database is, oh, it's Tim. Okay, does Tim have authorization for this resource? Yes, he does. I'll process the request, send back the response. So we see that quite often used for this type of thing right here. And so one of the interesting vulnerabilities I find when within JWTs using authorization is quite often they're not bound to a particular resource, okay? Maybe there's an application that's using JWTs in multiple places. Okay, well, what if the developer used these same claims for more than one accessible token, and it's all signed with the same key? So what I'm saying is maybe there's a token in one part of the application that's using the subject claim, and then there's another token JWTs being used in another part of the application for a completely different purpose that also uses a similar claim set. Can I take this token from over here and use it over here? And if I can, does it have a security implication? That's the question that I begin to ask myself. And the vulnerability is called JWT substitution. So let's jump into some pretty neat demos for this right here. Okay? All right. So now I'm going to go in, I'm actually going to modify my environment configuration here, and I'm going to turn on signature verification and encryption. So now not only am I'm dealing with a signed token, and I'm dealing with an encrypted token, which means this is the worst case scenario for the attacker, best case scenario for the developer. They have done everything they can within the JWT spec to lock that token down, okay? So it's locked down. Now I'm going to go and I'm going to log in as a user, another user. This time it's going to be Cooper. Okay. It's a passwordless authentication system when I'm not using OpenID Connect. So it says, hey, we sent you a code. So let me go over here and check Cooper's email. Cooper's got a code in here. And I'm Cooper, by the way, at this point in time. I'm not like a hacker, I'm just Cooper, all right? So I go to Cooper and I type in my code and I'm authenticated, okay? So now let's go look at this process here. So where's my delete? This is where I logged out previously. So here it is. So here I'm providing the email for Cooper, and I get back a 403 from the server that tells me, hey, the error means there's a code required, and there's something called a code token that came back with it, okay? So then what I do is that also tells the front end to say, hey, you need to go check your email and enter the code, right? So that's what I did. I went and checked my email. I had the code. I provided the code back through the interface. The actual interface also attached the code token to it, and it went back to the server. Now the server is going to take the code that it created and the one that it sent, okay? It's going to take that one, compare it to the one that I provided in the form, and if it checks out, I get an access token. Beautiful, okay? So then if I go up here and look at the users.me, sure enough, Cooper authenticated, here's his information, and he goes about using the application as normal. Okay. Now, the interesting thing about this process here is it's Cooper in and Cooper out. right? So Cooper went into the process by me entering Cooper's email address. Cooper came out of the process by also being the owner of the access token, but there's an exchange that happened through the process, right? There was a code token that was exchanged for an access token. So that to me, as an attacker, says, okay, in order for this process to happen the way that it did, there's a good chance that that code token and the access token are sharing a similar claim that just gets passed from one to the next. Not guaranteed. It's not guaranteed at all, but it's possible. And the simple fact that it's possible is interesting to me, because if they are sharing the same claim, then can I just take a code token, use it like an access token, and see if, and actually have it, and have the final endpoint, the users.me endpoint, actually receive that and say, oh, here's the claim I was looking for. That's Cooper. Well, let's give it a try and see how that works. Okay, so now what I'm going to do is I'm going to go in here, and I'm going to log out. And I'm going to try to log in as the admin again. Or not again, but I'm just going to try to log in as the admin. And there we go. I'm not the admin. I'm Cooper, right? So I don't have access to their email. I can't go get the token. Okay, I can't go get the token. So this is where I'm going to assume that this particular code token right here is potentially using the same claim as the access token. So I'm going to copy that code token there. I'm going to take it over to repeater, go to that same user's me, and I'm just going to overwrite this access token with the code token. Just because I'm assuming it's sharing that same claim. And if we go back one, I can't actually, can I? If we go back one there, let me, let's see if I can find that. Well, just take my word for it. How about that? The access token, if you open up the access token, it actually is that right there. That's what the claim set looks like. That's literally taken, copied, and pasted out of the access token in this particular application. That's what the claim set looks like. So I'm just assuming that the code token is sharing something similar with that, the subclaim, right? That's what I'm assuming here. And so let's go and let's do what I just did. I copied the code token over the access token, and I hit send, and again, I'm still authenticated, or I'm authenticated as the admin now. So I just used a code token as an access token. I never went through the whole process. I just assumed that maybe I can substitute one for the other because they share a claim set. And when this endpoint, when the application endpoint received the claim, when it received the claim, it said, oh, I see a subject in here. Signature checks, by the way, because I didn't modify the code. I didn't change it, or the token. I didn't modify the token. All I did was send a different one that was created using the same key, okay? And so by doing that, it passed signature verification. It gets read by the server. The server says, yeah, I see the subject claim, and it's user 6, and I can trust it because it passed signature verification, and it processed it, and it used it. So that's always a fun one for me to find that. I love when I see JWTs used in more than one place because I start tossing them around and seeing what happened. Now, this claim set, it could break things. So if this particular endpoint was looking at more than just the claims I provided, that could obviously break something, right? Because it may only see these 3 claims, but expect some other ones that aren't there. So it may not always work. There's some edge cases where it may break, all right? But in a lot of cases, it does actually work. Okay, so this was the most difficult scenario, right? This was the most difficult scenario there because we had everything protected. Everything the developer could do to knock down that JWT was done, and we were able to just substitute them and completely bypass authentication for this application. So we have another example here that I want to explore, and this one's we're going to go back to a more normal implementation. Okay, more standard implementation is going to be using JSON Web signatures versus JSON Web JSON Web encryptions, okay, as far as the structure goes. So it's signed, but not encrypted. This is pretty typical here. So I'm going to sign up for a new account now. So I'm going to go to the sign up page. I'm going to use TJT1980 at Gmail. This is my email address. If you want to hit me up, that's cool. Okay. Sign up. And it says activation token sent. So now I got to go back to my email. And this time I'm not using Cooper's email, obviously, because I'm not Cooper. And here I have email to TJT1980. This is me, and it gives me a link. So let's go ahead and activate my account. And I see account activated, please log in. So now I would be able to log in with that particular account using that passwordless system. Let's go look and see how that worked. So if we go to our proxy history here, see there's the delete. All right, here's a post. Actually, that was the incorrect one, right? It's still logging in. This is the one I'm looking for. Right there. Okay. So I send my email in. So this is the sign up page, right? I send in that particular information. I get back a success equals true, which means whatever checks that exist there, the duplicate user, whatever it is, it was valid. Valid email address. I passed all the normal validation. Sends back success equals true, which means that the server or the client now says, okay, you need to go check your email. I went and checked my email. I had the activation token. And so I post here the activation token, and I get back success equals true, and that tells me now your account's actually officially been created. So let's go ahead and let's actually look in this token here, because remember, it's transparent. We can see inside of it, and we're going to see some interesting stuff. See that right there? Email, name, avatar, signature. Did that look familiar? If we go back and we look at our original post for when we signed up, right there, okay? Remember, we're dealing with a stateless system here. The server is not going to remember the information that it received based on the registration request. So in order for it to know what user it's creating an account on behalf of, that information has to be inside the token. It's stateless, remember? So it provides the activation token, which has all the information that I used when I registered, and then it sends it back to verify that I did actually own the email address, and then it says, okay, now I can trust you. You own that email address. I'll create the account based on the information that's in the token. But that looks like exactly what I typed in there. So what happens if I add other claims to when I initially created my activation token? What if I added claims there that it didn't expect? Would they show up here? Let's find out, okay? So I'm going to go back here to our original. This is where we posted it, right? I'm going to modify this. Let me send this over to repeater. And I'm going to modify this, and I'm going to add like the payload foo bar, because it would not be a code conference if somebody didn't use foo bar. So I'm going to get it started right now, foo bar, okay? Hit send, and now we got this, and it says go check your email for an access token. I go refresh my mail. Sure enough, I got a new access token. Let me open this up here. And of course, it's going to tell me that the email address already exists, which is fine. I don't really care about creating a new account. I want to see that activation token. So now I go back to my proxy history, and I look at the post. Here's my activation token, decode it, and look at that. Foo bar. So I'm in a situation where it looks like I can forge a token. I can actually add whatever I want to it. Well, what if I could overwrite as well? If I can add, potentially I can overwrite a claim that's already there. And then we can see here that there is a subject claim here that says new user. Well, what if I overrode new user with like, I don't know, user number 1? And I just submitted it as an access token instead of a activation token and see what happens there. So let's try that now. So I'll go back to repeater, and instead of using foo bar, I'm going to do sub, and we'll make it an integer, 1, and submit it. Success, true. Go back and check our email here. Right click, and I just overdid that, but that's okay. Email already exists, but that's fine. All right, that's what we expected to see. And if we look at the post request here, check it out. So we did overwrite the subject. And that's pretty common behavior. There's, oh, really? Man, okay, he's going to kick me off stage. All right, so we overrode it there, okay? So that's pretty cool. Now now that we can probably take this activation token, take it back over to our repeater, go to the user me thing, paste it, hit send, and once again, we've forged an administrator token, okay? We forged it and then substituted it. Forged it and substituted. So this is another way that we can beat up on JWT implementations that are used in authorization scenarios, okay? So let's do one final scenario before we close out. And this last one is JWTs and information exchange. Now, as I said, that's kind of a subset for everything. We're always exchanging information with JWTs. That's what they do. But this is a catch-all for all the other types of tokens that we might see that don't fall into authentication or authorization. And maybe they even do, but whatever. This is just kind of my catch-all here. So things like reset tokens, activation tokens, code tokens, a lot of the things I've been throwing around that aren't officially a part of a spec or anything like that. They're just things. Okay? Well, once again, JWSs are transparent. We can see what's inside of them. And most of the time, the information is not sensitive. But that's not always the case. Most of the time, it's not a problem. And a lot of the things I hear back from developers are, well, my client owns the token, so what does it matter if they can see inside of it? Even if it has my password in my token and I've seen it, I don't know why, but I've seen a password in my token before. Even if it's there, why is that a problem? Because it's my password. I own the token. Well, there's lots of problems with that we won't get into details there. All right, but the bottom line is integrity is the priority. Okay? Integrity, that being able to change, is the priority. But sometimes the ability to see that is also a problem. Number one, they're typically stored in local storage. If you're passing a token as a cookie, like that's fine. You can pass a token as a cookie. It's possible to do that. But usually it's not done that way. Normally it's stored in local storage, and then the front end is responsible for taking that information and sending it back to the client. So it's typically stored in a place called local storage. Well, guess what local storage is exposed to? Client-side scripts. And so if there's a cross-site scripting vulnerability or something like that, I can just read your token straight up out of your local storage, and I can see the information that's in them. I can either use it to become you, or I can see the sensitive information that's in it and leverage that information. Otherwise, if somebody just comes and sits down at your terminal because you didn't log out or you didn't lock your terminal, they could go into your local storage and see what's there. Or any kind of remote access. If somebody has remote access to your system, they could also check local storage. So sometimes it's a problem if you got sensitive information in there because of these things right here. And sometimes even the bearer themselves, me, you, the owner of the token, should not know what's in our token. I dealt with a situation once where I was dealing with a token that had like a upload path in it or something like that. Like when you uploaded documents, it went to one place on the file system. And the path was something like, slash whatever the prefix was, and then there was like a hash at the end of it. And I took that hash, and what do you guys do with hashes when you see them? If you're security minded, you ask Google. Like always ask Google about hashes, because Google will reverse hashes for you sometimes. So I just took it and I Googled it, and it hashed, and basically the hash was the hash of my user ID. So they basically took the user ID, hashed it, and used it as a unique folder on the hard drive. Well, what could I do with that information now? I could just take somebody else's user ID, hash it, and then I would know right on the file store where their information was. So if I ever found a path traversal vulnerability or something that gave me the ability to read the file system, I could now knew where to go look for other people's files on the file store. Okay? So I should not have been able to see my own upload path because I was able to infer information about other users because of it. So it's not always a problem, but it can be. Okay? But what if a developer failed to encrypt something that is really, really sensitive like that? Not even more sensitive to that. Well, let's go ahead and let's explore a situation that I actually came across in real life twice in 2023. So once again, I'm going to log in as Cooper. So let's go here and log in as Cooper. And I wish I had autocomplete, but I was a good developer and turned it off. At least on fields that shouldn't have autocomplete, right? All right, so go back to my inbox here. I got to go to Cooper's email because I've changed identities. All right, we'll copy his code, come back here and log in. Okay, here we go. I'm logged in, and we've already seen this process, right? We know that. Let's see, where's my log out? There's my post. There we go. So we've already seen this process. I get the code token back, and then I am prompted to get my code. I have the code, and I send it back in. Well, remember, this is a stateless system. So just like the demo we did just a minute ago where we were able to forge a token, and it had to be passed to the client so they could come back, well, that's exactly what the code token is. It has to have that code in it so that when I send it back, the server actually has something to compare my token to, or my code to. Because otherwise, it's stateless. It doesn't have any memory about where I am or what I did previously. And so if we look inside of our code token, we will see that the code is there. Okay? And that's how it works. So now I pass the code token back. I submit the code I got in my email back. The server receives that, it looks in the token, sees the code, sees the one that came back in the form, matches them, I prove my identity, you're good to go. There's a huge problem here. Did anybody catch it? Tokens are transparent by default, okay? So if I go back here now, I'm gonna try to log in as the admin. And once again, remember, I do not have the admin's email. So I can't go check his email. I can't verify that I'm him. But what I can do is just go to this code token that was given to me, copy the code out of it, and I'm authenticated as administrator. So 2023, got a client, and I found this vulnerability. And I'm like, got his cell phone number, okay? I got his cell phone number because I'm working directly with him. The developers actually happen to be really close friends of mine. So I'm working on this, and I'm like, okay, this is gonna be good, all right? So I get that, and I get the token back. You know, he obviously gets the text message that says, oh, you have a token, you know, to log in. He's like, you know, I didn't do that. Tim must be up to something, right? And then about 30 seconds after he receives the text message, he gets a picture from me of me logged in as him. And I immediately get a response back that's like, we need to talk. So I was able to explain to him. Immediately he knew exactly what he did wrong. Immediately he's like, oh my gosh, I forgot to encrypt the token. You just pull it right out of the JWT. I'm like, yes, I did. Encrypt your tokens, man. It's sensitive information. All right. So that's what I ended up doing. And then I found the exact same vulnerability on another application a couple months later. Okay. Now the same developer may or may not have worked for both of those companies. Okay. So it might have been something going on there, but I'm not willing to throw him that far under the bus. All right. For all intents and purposes, brilliant developer, has written a lot of really good code, just made a simple mistake that we can all easily make, okay? So those are some things that you want. They don't always have to be, and by default they're not, okay? By default, tokens are always signed by default, but never encrypted by default. You have that choice to make as a developer, but understand the sensitivity of the information that you're passing, and then make the right decision on how you proceed. Okay, so some responsible JWT usage. Number one, for missing signature verifications, just verify the signatures on untrusted tokens, right? Check your stuff. Always verify them. Luckily, every library does this by default. So even though they're all broken horribly from a crypto standpoint, they at least do this for you by default. They will actually check the signature by default. You have to turn it off for that not to happen. From a JWT substitution standpoint, okay, this is when I'm taking one token from one place and using it for another. Those are two different endpoints. Those endpoints are called audiences. There's literally a claim in the JWT spec called AUD, which is meant for specifically that. You say this token is only meant for this audience, and then you check for that audience claim on the server when that endpoint receives it, so it will only accept tokens that are intended for itself. There's a whole claim in the spec for that, not done by default. It's something you have to implement, okay? The next thing would be to use, you don't want to use the audience claim, which is fine. Another thing you could do is use a unique signing key per resource. So the thing that processes the code token uses a key, a signing key that's specific for that token. The thing that receives the activation token has a specific key that it uses to sign that one. And so you're going to get the similar result here, is it's just not going to work. As it's just not going to work for other resources, but you're using a different signing key versus a different audience. Personally, I don't like that. I don't want to manage multiple keys. Personally, I'd rather just check for the audience claim, but it is a technical way to remediate that issue. Now, the forgery variant, that's all about validating inputs against expected claims. If you've never heard of mass assignment, this is very similar to that. It's where we're just trusting a bunch of data, bundling it up, and using it somewhere else without explicitly looking at it to validate it, okay? So some things you can do there, explicitly bind inputs, have a line of code that says this is gonna be this, and this is that, taken from one place to the other. You can do that manually. You could use a data transfer object. You could use a schema or something like that, and you bind it to the schema, and then you use the information that comes out the other side, so you're only getting what you expect, but filter out claims that you don't want. That's basically what you're doing there. And then from a JavaScript JWT information disclosure, encrypt your tokens. Okay, you just encrypt, encrypt, encrypt. If there's sensitive information or anything that can even be sensitive, you want to encrypt it. It is going to add some overhead, so there is a downside to that. Use it responsibly, but that's what you should do. Okay, and then the final thing, like specifically what we were in this application, the whole 6-digit login passwordless code, I recommend using a magic link instead. Just using a magic link that they click on that sends a much larger token is a way safer thing than trying to have a stateless system manage this little 6-digit code. So I would highly recommend magic links instead of the other. In fact, I'm implementing an app right now, passwordless, using magic links. Okay. All right. So to conclude, okay? The JWT specification, lots of pitfalls, okay? There's a lot, not just crypto problems, but ways that you can implement them insecurely, just in a normal way that they are expected to be implemented there. And there's more of an attack vectors than I've mentioned here, but I think these cover the really fun ones, the ones that I think developers don't think about as much. But this is a great quote I love about crypto here by this particular individual. If crypto standards give users enough ropes, they will hang themselves. And think of the JWT specification as like a bag of ropes. It's just giving you a bunch of ropes. Here, take all these ropes and do something great with them, and then you can totally hang yourself with those ropes. So be careful with how you implement it. As you can see, a lot of damage can be done if it's not fully understood. Kind of like using like a drill for a toothbrush. It's not going to work out real, right? Okay. But it's a core component of web apps today. It's a core component of web apps today, so the ability and the understanding on how to implement them securely, super duper important. Here's some resources that'll be in the slides and some credits. Here's some information about me. I'm actually teaching my web app pen testing class and my Burp class over the next 2 months. If you want to learn more of stuff like this, even as I get a lot of developers in my class too that want to be either security champions or just know how their stuff's getting busted, right? Definitely sign up for those. You can email me or just go to my website, and I have all the events and stuff listed there.